Today we're going to take a look at comparing independent events, which is when two events do not affect the outcome of one another. So for example, when you roll a die and then you roll it again, what you rolled the first time doesn't change what could possibly happen when you roll it the second time. The second type of event we're going to look at are dependent events. And that's when one event does change what could possibly happen for the next event. So for example, if you're dealing cards from a deck, if you deal a red 5, that's not left in the deck to deal from, so it changes the probability for what's left. So first we're going to review independent probability. This is what we did in class on Friday. And that is when, again, the first event, does not change what could possibly happen for the second one. So if Jeremiah makes 75% of the shots he takes when his mom is goalie, and Eli makes 90% of the shots, we're going to calculate some probabilities. So the first thing you do is calculate each probability separately in simplest form. So for part A, our first question is what's the probability that Jeremiah does make it? These aren't fractions, but we do have to, in this case, convert it to a decimal before we can multiply with it. So 75% is 0.75 as a decimal. And so we multiply by Eli does not make it. Remember, this little symbol here means not. So if Eli makes 90% of his shots, he does not make 10% of them, converting that to a decimal. As mentioned, we multiply, and then if they were fractions, we would simplify again. What we're going to do is convert it back to a percent. So this would equal 0.075 or 7.5%. All right, example 2, what's the probability that Jeremiah makes his first shot and then misses or does not make his second shot? So converting that 75% again into a decimal. And if he makes 75% of the shots, he will miss or not make 25%. Multiplying those together, we get 0.1875 or 18.75% chance that he will make the first one and miss the second one. All right, the last one, what's the probability that they both make it? So Eli has a 90% chance of making it. Jeremiah has a 75% chance. Multiplying those together, 0.675, and then converting it back to a percent, 67.5% chance that they both make their shots. So now we're going to take a look at the new material, the dependent events. So this is when the first event changes the probability for the second event. So Kai is grabbing socks from her drawer. When she picks a sock out, she keeps it, which means there's fewer socks in the drawer left to choose from. So the process for finding the probability is the same, except for you have to change the probability for your second event. All right, so our first probability is that she pulls a pink sock and then a red sock. So the pink sock is normal. There's 12 pink socks in there out of a total of 30 socks. The and means we will multiply, but think about this. She's got a pink sock in her hand now, so that means there are 29 socks left in the drawer for her to choose from, 6 of which are red. Okay, I'm going to put these in simplest form before I multiply to make it a little bit easier. So 12/30ths simplifies, we can divide them each by 6 to get 2/5, and 6/29 does not. So when we multiply these together, we get 12 out of 145. Now, a 12 out of 145 chance probably doesn't mean a whole lot to you, so I calculated these as percents as well, and this is an 8.3% chance that she'll pull a pink sock and then a red sock. All right, so let's take a look at what happens if we wanted to pull a white sock and then a white sock. So again, calculate each probability. The first chance that the sock is white is 8 out of 30. It's out of 30 because now we're starting all over. We're assuming she hasn't pulled any socks out. These are different questions, so we're not continuing that she's still got the pink and the red in her hands. She's starting all over. And again, there's 29 socks left in the drawer because she's holding a white one. There's also 1 fewer white sock in the drawer. She has a white sock in her hand, so now there's 7 white socks left out of the 29 in the drawer for her to pull from. Simplifying each of our probabilities, 8/30ths, they both divide by 2. 7/29ths does not simplify. When we multiply these together, we get 28 out of 435. And again, to convert that to a percent so that it makes sense to us, she's only got a 6.4% chance of pulling out 2 white socks in a row. Last question, what's the probability she pulls a multicolored sock and not a multicolored sock? So there were 4 multicolored socks out of 30 in the drawer. And not multicolored, there were 26 other socks in the drawer, but she's got the multicolored one in her hand, so there's 29 socks left. Simplifying 4/30ths to 2/15ths, multiplying that by 26/29ths gives us a 52 out of 435 chance of pulling a multicolored and then not a multicolored, which equals approximately 12%. And your U-Try questions. So on this first U-Try dealing cards from a deck, if you forget what's in the deck, go back to your Learning Target 33 notes where I listed all of the different types of cards that are in a deck.
Brian Cochran,